So today lecture we talk about the linear independence, the basis, and the dimension of vector spaces. Now we move to linear independence and linear dependence. What's the meaning of this concept? Consider a set of vectors in our vector space. Here we are interested in the case where the linear combination is zero, the zero of V. Okay, so here we study the homogeneous system as we did in lecture 4, when the right side is zero. So if قلنا homogeneous system is always consistent. If it has a unique solution, this will be the trivial solution 0, 0, 0, 0, or sometimes it has infinitely many solutions. So if the system has only the trivial solution, has a unique solution, we say it's linear independent. So the only way to have this zero is that all the coefficients are zeros. So in this case, the system is called linearly independent. The vectors v1, vk are independent. There is no relationship between them. We cannot write one of these vectors in terms of the other vectors. But if the system has infinitely many solutions, has other solutions than the trivial solution, it's called linearly dependent. And if the set is linearly dependent, means that one of the VI's can be written in terms of the other vectors. The set of vectors is linearly independent if and only if none of the vectors is a linear combination of the others. They are independent. There is no relationship between them. We cannot express one of them in terms of the others. So, for example, determine whether the following set of vectors is linearly independent or linearly dependent. Okay, so these are elements of R3. And here again, we have to show that the homogeneous system has a unique solution 0, 0, 0. So writing the row echelon form for the homogeneous system. So it's clear here that C3 is 0. Since C3 is 0, C2 is also 0, and C1 is also 0. So here we have unique solution 0, 0, 0. So this set is linearly independent. Determine whether the following set is linearly independent or linearly dependent. Again, so these are here elements of P2. So it's a subset of P2, the set of polynomial of degree less than or equal to. Again, we have to solve the homogeneous system C1 V1 plus C2 V2 plus C3 V3 equals 0. So here, if we replace V1, V2, V3 each by its expression, C2 times 2 plus 5x minus x square, C3 x plus x square equals 0. So here we remove parentheses and we collect like terms. Okay, so as a constant we'll have C1 plus 2C2. This is the constant terms. As terms in x we'll have C1x, 5C2x, and C3x. And in terms of x square, we'll have minus 2C1 minus C2 plus C3, x square equals 0. And we obtain the system. A polynomial is 0 for any value of x, is always 0. This means that each of the coefficient is 0. So this is the system obtained in this case. And again, we build our augmented matrix, the homogeneous system. So 0, 0, 0. And we transform it into row echelon form. This is the system. This is the augmented matrix. This is the row echelon form. And here we see that we have infinitely many solutions. So is it linear independent? The answer is no. It's linearly dependent. So here we have infinitely many solutions. So these vectors are not linearly independent. They are linearly dependent. So here if you solve, so C3 is free variable. So C3 is t, for example. So C2 is -1 over 3 t, and C1 is -2 C2. So it's 2 over 3 t. So the solution set of this system is 2 over 3 t -1 over 3 t, t, t in R. So the set S is linearly dependent. And again, what does it mean linearly dependent? So here, for example, to simplify, if we take t equal 3, for t equal 3, for example, what is the solution? It's 2 minus 1. 3 is a solution of the system. Okay, which means that 2v1 minus v2 plus 3v3 equals 0. إذا نجيب v2 من هنا means that v2 is 2v1 plus 3v3. So there is a relationship between v2, v1, and v3. v2 is a linear combination of v1 and v3. So they are not independent, they are related, they are dependent. Okay, you can't check this. What is 2v1 plus 3v3? It's 2 plus 2x minus 4x squared plus 3v3 يعني plus 3x plus 3x squared. If we simplify, we get 2x plus 3x, 5x, minus 4x squared plus 3x squared is minus x squared, and this is exactly v2. So v2 is a linear combination of v1 and v3. Okay, so this set is not linearly independent. Now this is important. So since the system has infinitely many solutions, particularly this is one of the solutions, there are infinitely, so they are linearly dependent. So now we are in the set of 2 by 2 matrices, M2 by 2. So these are 3 vectors in this set. Are they linearly independent or linearly dependent? So again, we have to solve C1v1 plus C2v2 plus C3v3 equals 0. The question is C1 equals C2 equals C3 equals 0 or not? Do we have unique solution or not? So what's C1v1? C1v1 is C12101 plus C2v2 3021 C3v3 1, 2, 0, 0 equals 0. So we multiply the matrix by scalar, we add, we obtain 2C1 plus 3C3, 2 plus C3. Here 2C2 plus 2C3. Here C1. Here C1 plus C2 equals 0 of the matrix is 2, 2, so equals 0, 0, 0, 0. So I repeat, this is the 0 of the vector space. This is the 0 of M2 by 2. It's not the scalar 0. So matrix equals 0, so we obtain a system of 4 equations here. 2C1 plus 3C2 plus C3 equals 0. C1 is 0. This is given. 2C2 plus 2C3 is 0. And C1 plus C2 is 0. So the second equation, Tatini, also C2 is 0. And then the third equation, C2 is 0. And this equation, 0 plus 0 plus 0 is 0, is satisfied. Okay, so yes, we have unique solution, which is the trivial solution. So what's the conclusion? Yes, S is linearly independent. Okay, there is no relationship between these three matrices. This is the idea.
دكتور أنا أبغاك بس توضح آخر خطوة.
الحل هذا عنا two matrices equality of matrices شفناها lecture 2 شو معناها؟ يعني هذا زيرو هذا لازم زيرو هذا زيرو هذا زيرو صح؟
إيه صح صحيح.
فيصير عنا 4 equations you solve لكن 4 equation عنا already C1 is 0 خلاص فإذا C1 is 0 تعوضوا هنا 0 plus C2 is 0 so C2 is 0 فهمت؟
إيه إيه الحين
إذا تعوضها هنا
لما
C3 is
مشيت معي
0
خطوة خطوة استوعبت.
Okay, why do we study linear independence and span? So this is recall if any linear combination equals 0, this means that all coefficients are 0. In this case, our system is linearly independent. Otherwise, it's linearly dependent means that one of the vectors here in this list can be expressed in terms of the others. And in this case, if Vn is a linear combination of V1, Vn minus 1, the span of these n vectors is the same as the span of the n minus 1 vectors removing Vn. لأنه Vn ما يضيف لي ولا شيء لأنه هو already I can write it as V1, Vn minus 1. فهمتوا؟ So the set is spanned really by n minus 1 vectors, not by n vectors. مثلا هنا وانا شفناهم linearly dependent هذم قلنا linearly dependent. So the span of S, so قلنا هنا V2 نسيت هي 2V1 plus 3V3 صح؟ So span of S هو نفسه the span of V1 and V3. Okay, so the vector space spanned by S is spanned only by V1 and V3 really. لأنه V2 هي itself a combination of V1 and V3. Okay, so for this example, span of V1, V2, V3 is the same as the span of V1 and V3 only. V2 is related to these two vectors. Okay, ما تصنع لي شيء جديد. This is the idea. And now we are ready to talk about the basis of a vector space, الأساس اللي بيه راح نبني the whole space, and the dimension of the vector space, البعد. So we studied spanning sets, we studied linearly independent sets, and the intersections of these two sets is called a base of my vector space. Okay, so a base is a set of vectors which is spanning the set and linearly independent. So in a vector space, if we consider a set of vectors v1, v1, n, if S spans the whole space V and if S is linearly independent, then S is called a basis of V. Okay? And any element of V can be written as a linear combination of the vectors of this set. And not only that, but in a unique way. It's a linear combination and in a unique way. Okay? So في الحالات اللي لقينا فيها infinitely many solution, this means that this set, even it spans the full space, okay, it's not a base. Okay, it's not linearly independent because we have several options. To be a base, لازم it spans, it's linearly independent. Any element is a vector combination in a unique way. We'll see this in more details later. And so it's important that a basis must have enough vectors to span the whole space, but not so many vectors that one of them is a linear combinations of the others. So you need the right numbers of vectors to have a base. Okay? So as we have quickly talked about in the previous slides, this set of three vectors is the standard basis of R3. On any element of R3 can be written in terms of these three bases اللي هم يعطيونا x axis, y axis z axis in R3. Okay? So 1, 0, 0 هو x axis, 0, 1, 0 هو y axis, and 0, 0, 1 is the z axis. So the standard basis of R4 is these four vectors, for example, and so on. So for Rn, it has the standard basis of n vectors. E1 L1 في the first position, others 0. E2 the 1 in the second position, the others 0, and so on. En 1 in the last position, and other coefficients, elements are 0. The standard basis of the set of matrices of order m by n is this set of four matrices. So any matrix, and the matrix 5, 7, minus 2, 3, can be written in terms of these four matrices. 5 times 1, 0, 0, plus 7 times 0, 1, 0, 0, minus 2 times 0, 0, 1, 0, plus 3 times 0, 0, 0, 1. So it's a spanning set. So span of S is the whole matrix set of order 2 by 2 here. And we can show that S is linearly independent. Okay? Linearly independent, spanning set. So it's a base. It's a base. Any elements of the vector space can be written as a linear combination of this set in a unique way. So the standard basis of Pn, the set of polynomial of degree less than or equal n, is 1 x squared, x cubed, xn. This is the standard base of this space. So for P3, the standard base is 1 x squared, x3, and any vectors Any polynomial in P3 can be written as A0 times 1, A1 times x, A2 times x squared plus A3 times x cubed. Okay, A0, A1, A2, A3 are scalars. They are the coefficients of this polynomial with respect to this space. So if a vector space V has a basis with n vectors, if we know that V has a basis of n vectors, so then every basis has 3 vectors. Okay? All bases of a vector space have the same number of vectors. Okay? So نعرف إنه R3 has a base 1 0 0 0 1 0 0 0 1. How many vectors are there in this base? كم vector عندنا? We have 1 2 3 vectors. So any base of R3 must contain exactly 3 vectors. كان يعطيوك set فيه 4 vectors يقول لك show that it's a base of R3. قولوا no, this is not correct. Any base has 3 vectors only of R3. No more and no less. Exactly 3 vectors to be a base. And the number of elements of the base of a vector space is called the dimension of the vector space. Okay, so for example here, what is the dimension of R3?
دكتور عندي إجابة بس مو متأكدة.
قولها صحيح غلط قاعدين نتعلم احنا.
3 dimension.
The dimension is 3 قلنا because this is the base of R3. كم فيها من vector? 3 vectors.
3
So the
factors.
dimension is 3. What is the dimension of R4?
4 عشان عندنا
Because
4
this is the
factors.
base. فيها 4 elements. What is the dimension of the set of matrices of order 2 by 2?
2 by
This
2.
is the base of this set of square matrices of order 2. كم فيها من element?
4 elements.
4. What is the dimension of this space?
4.
It's 4. What is the dimension of P3? The set of polynomials of degree less than or equal 3. So قلنا this is a
4.
basis. كم فيها من element? 1
4.
2 3 4. So the dimension of P3 is 4. مش
is
خاطر
4.
يكتب لك 3 معناها لازم 3. Be careful. The dimension is the number of vectors in a base of this space. Okay? So the dimension of P3 is 4. اتفقنا؟ إنه
Okay.
فيه الإكس كيوب فيه الإكس سكوير فيه الإكس وفيه الكونستنت. So this is what we call the dimension. So a set of linearly independent and spanning the whole space is a base. If a set is spanning the whole space and the number of elements of S is the dimension of V, the number of element of S dimension of V, إذا عندك linearly independent يعطيك spanning set. يعني span of S is the whole space. If the number of element of S is the dimension of the space and span S is the whole space, يعطيك S is linearly independent. And of course, if S is linearly independent and span S is the whole space, so S is the base of V. Okay, so if we know the dimension of V, مثلا إذا نعرف نشتغل في R3 we know that the dimension of R3 is 3. إذا أعطاني a set of 3 vectors قال لي show that this is a base يكفي إنك توريها linearly independent ولا توريها spanning set. ما يحتاج إنك توريهم الاثنين. واحدة is enough because we have the correct number of vectors in the set. فإذا هي 3 vectors linearly independent يعني we are sure it's a base of R3. Okay, if it's 2 vectors it's never a base. If it's 4 vectors it's never a base of R3. But 3 vectors إذا هي linearly independent or نعرف اللي هي spanning R3 so it's a base. And this is the idea. So given a set, to find the basis of the spanning set of S, we form a matrix whose column vectors are V1, Vn. We reduce A to row echelon form, okay? And the vectors from S corresponding to leading one are bases of span S. So the spanning set is not always the whole set. Let's solve examples. Show that V1, V2 is a basis for Rn. إذا قلنا المفروض to show that this set is a basis of R2 لازم we show that it's linearly independent and a spanning set. لكن الفكرة ايش تقول لي؟ تقول لي here the cardinal of S, the number of element of S is how many elements of in S? How
two
many elements?
elements.
It's 2. What is the dimension of R2?
2.
So the number of elements is equal to the dimension. So ما يحتاج هذه يكفي انه نعمل هذه or هذه لانه عنا this information. فهمت؟ المفروض
Yes.
هي and. But if we have an extra information that the number of elements equal the dimension of the space تصير or يكفي واحدة من الاثنين. And usually to show that set is linearly independent is easier than to show that it's spanning the whole space. Okay? So يكفي انك you showed that it's so enough to show that S is linearly independent. Okay? ايش معناها linearly independent? So we solve the homogeneous system V1, V2, 0. So 1, 1, 1 minus 1, 0, 0. R1, R2. If we do R2 minus R1, R2, we obtain 1, 1, 0, 0 minus 2, 0. So this means that this we have two leading ones. So minus 2 C2 is 0, so C2 is 0. C1 plus C2 is 0, so C1 is 0. Okay, this means that yes, S is linearly independent, so S is the base of R2. Okay, so no need here to show that S is a spanning set. So يكفي انك you solve the homogeneous system, no need to solve the full system. People sometimes also show that to show that it's a base, they show that the determinant is non-zero. This is also possible. Show that this set is a base of R3 again. So the number of elements of B is 3. It's the dimension of R3. Okay, so we have to show that B is linearly independent. Okay, so again, we can calculate the determinant 1 non-zero. So it's a base, or we solve the homogeneous system and say that the only solution is the trivial solution. Look here. So we have 3 vectors. صح؟ V1, V2, V3. We are in R3. The dimension of R3 is 3. But we are not sure that these three vectors, the set of these three vectors is linearly independent. مو أي ثلاثة vectors راهم linearly independent. فهنا قال لي prove they are linearly independent. So if they are linearly independent, then it's the base. So you can calculate the determinant or you can solve the system, homogeneous system. So since they are linearly independent, three vectors, so, and the dimension is 3, so it's a base. Find the coordinates of a vector relatively to this base. In this case, you solve the system. So you have U is C1 V1 plus C2 V2 plus C3 V3. You have to solve the system 2, 1, 0, 3, 2, 1, 1, 0, 1, 2, minus 1, 0. Find C1, C2, C3, and this will be the coordinates of the vector in this new base. So usually these coordinates are related to the standard base. Here 1, 0, 0. 0, 1, 0, 0, 0, 1. Okay, this is the standard. هنا عنا a different base, so we'll have different coefficients. Okay, so for example, if we do, for example, 2R2 minus R1, R2, we'll get 2, 3, 1, 2. 2 minus 2 is 0, 4 minus 3 is 1, minus 1, minus 2 minus 2 minus 4, 0, 1, 1, 0. Finally, R3 minus R2, R3. We obtain 2, 3, 1, 2, 0, 1, minus 1, minus 4, 0, 0, 2, 4. This means that 2C3 is 4, so C3 is 2. C2 minus C3 equal minus 4 means C2 is minus 4 plus C3 is minus 2. And 2C1 plus 3C2 plus C3 equals 2 means that C1 is 3, I think. Okay, so what are the coordinates of U in terms of this new base? It's 3 minus 2,
minus 2, 2.
2 relatively to this base S. Okay, it's written minus 3V1 minus 2V2 plus 2V3. Of course, if you change the base, you change the coordinates. Okay, these are the coordinates relatively to the standard base, and these are the coordinates relatively to the new base. So we can modify bases and looking to the base which is more efficient for us. Okay, it's not always the standard base which is the most efficient. Okay, we'll see that later. So the solution of the linear system give me the coordinates of U in terms of the new base. Determine whether this set is the basis of M2 by 2. So what do you think? Is it the basis of M2 by 2, set of matrices, square matrices of order 2? Yes, no? But I will ask another question. Do you know the dimension of this set? Who knows the dimension of this
4.
set? قلنا
4.
4 شفناه هنا previous slides. So this is dimension 4. شفنا already a base of M22. This was a base of M2 by 2 matrix space. This base كم فيها من vector قلنا 4, so the dimension is 4. وهنا الست يعطاني إياه كم فيه من factor. What's the number of elements of B? How many factors are there?
3.
3. So here we see that these numbers are different. So, of course, B is not a base. Cannot be a base of M2 by 2. It doesn't have enough factors to be a base. Show that this is a base. So again, so we can. So here, قلنا what is the dimension of P2, the set of polynomial of degree less than or equal to. قلنا the dimension is 3. And it's the number of elements of B. Okay, so show that B is linearly independent. To show that, for example, we can write the matrix 1, 1, 0, minus 1, 1, 0, 0, 0, 1, okay, and calculate this determinant and show that it's not a 0. This means that it's a linearly independent set of 3 vectors. Dimension of P2 is 3, so it's a base. Now, let's see this set. How many vectors do we have in S? How many elements in S?
5.
It's 5. S is a subset of which vector space? The elements of S وين موجودين؟ وين يعيشوا؟ This element وين موجود؟ في S, but also in this is a vector of R3. So here we are in R3. What is the dimension of R3?
3.
What is the number of elements of S? قلنا 5.
Yes.
هل S is the base of R3? Of course not. The number of elements of S is not the dimension, so it's not a base. هذه is not a base of R3. ليش is not a base؟ فيها زيادة elements، لازم يكون فيها 3 حتى تكون base. فايش معناها اللي فيها أكثر من 3؟ يعني ماخذين vectors زيادة ما نحتاجهم. They are مربوطين ببعض. They are linearly dependent. So to find the basis for the span of S, ايش لازم نشوف؟ شوف the row echelon form, the leading one. The columns of leading ones يعطيونا a base of span S. So here, this is the matrix. This is the row echelon form. This is the coefficient matrix. This is the row echelon form. How many leading one do we have? So this is the leading one, this is the leading one, this is the leading one. We have 3 leading ones. When the first column, the first column, second column, third column. What does it mean? It means that if we take the first vector, the
يعني راح
second
نحذف
vector, and the
البقية.
fourth vector, we obtain this is a base of span S. And since here the 3 vectors, it's also a base of R3 as well. Okay, so you take the first vector, the second vector, and the fourth vector of the list, and this is a base of span R3, which is a subspace of R3.
Yes.
And here the dimension of S is 3 because the base of the span S is contains 3 vectors. Determine the dimension of subspace of R3. So this W is a subspace of R3. What's the dimension of this subspace? So here the elements were written D, C minus D, C. So we can split it into vectors. اللي فيهم only D's or only C's. We split it in this way. We make D common factor, C common factor. So this means that the set of these two vectors V1, V2 and 0, 1, 1 is spanning the whole set W. So W is spanned with two vectors. This means that the dimension of W is less than or equal to. It's clear that these two vectors also are linearly independent. So two vectors in W are linearly independent, so the dimension of W is greater than or equal to. So these together, it's a spanning set, it's linearly independent. This means that the dimension of W is 2. Okay, so this is a proper subset of R3. It's not the trivial subset. And this is a base of W. These two vectors is a base of W. What about example 2? What do we expect? What is the dimension of W? Example 2. حسب رأيكم هنا. What is the dimension of W? Let's see, these are elements of W. So if you write B210, so we say that if this is V1, spanning set V1 is the whole W. And since it's one vector, مع حاله هو لحاله linearly independent, so V1 is the base of W, and the dimension of the subspace is 1 here.
1. Yes.
It's a subspace of dimension 1. Okay, and 210 is the base of this subspace. The last example, I think, W, the subspace of all symmetric matrices of order 2. شو معناها symmetric matrix of order 2? How can we represent a matrix in W? شو معناها symmetric order 2 symmetric؟ كيف شكلها؟ So here A, C, and لازم هذا B, لازم A transpose equal A. So لازم A21 equals A12 equals A21. So this is the expression of characterization of the symmetric matrices of order 2. So حسب رأيكم W هذا شو راح تكون الدايمنشن متاعه؟ نعرف dimension of M2 by 2 is 4.
4.
What's the dimension of the subspace of symmetric matrices? So here it's a vector space of dimension 3 only, the set of symmetric matrices.
دائما
Because-
السيماتريك 3.
Because you can write it okay, so we can express any symmetric matrix as a linear combination of these three matrices. And these three matrices are symmetric, are elements of W. So if we call this, I don't know, V1, V2, V3, so the span of V1, V2, V3 is W. This set is linearly independent. We can show it. So this set is the base of W, and the dimension of W is 3. So the set of symmetric matrices of order 2 is a vector space of dimension 3. Whereas the set of all matrices, square matrices of order 2 is a vector space of dimension 4.
دكتور بس عندي
Yes.
سؤال. احنا قلنا الدايمنشن 3 لأن في السيمتريك إنه لازم يكون لا، في السيمتريك المفروض مو في عنصرين يصيرون ايكوال بعض، عشان كذا قلنا 3 ولا لا؟
لا هنا symmetric of order 2 symmetric of order 3 راح تكون اوكي لازم it satisfies the definition of symmetry in order 3 راح تكون كده شكلها. عندك A11 A12 A13 هنا هذا راح يكون نفسه A12 هذا راح يكون نفسه هنا راح يكون نفس ال A13 هنا راح يكون نفس ال A23 فهذا وهذا the same هذا وهذا the same هذا لا مش هذا هذا وهذا the same you agree صح؟
اي انا اقصد
لا.
ان عشان كذا
Hey,
ان
what is the
ماتريكس
dimension of M3 by 3?
9.
9. What is the dimension of هذا W symmetric matrices of order 3?
6.
6. Okay.
اي اوكي.
Subspace of dimension 6 in a space of dimension 9.
اي واضح.
So here a base of W فيها 6 vectors 6 symmetric matrices اللي تبني بهم W كله.
اي واضح.
يجيك 1 واصفار مثلا هذا مثال واحدة من الستة وفي واحدة مثلا تجيك كده في واحدة ال1 هنا وفي واحدة ال1 هنا وفي واحدة ال1 هنا عندك ستة تبني بها the whole W. So this is how to now we are ready to build any spaces, any objects, any everything properly. Okay, with this concept.